August 1st, 1943, 2 o'clock hours, Benghazi, Libya. The desert air is deceptively cool, but inside the cockpit of a B-24 Liberator nicknamed Witchcraft, the heat is stifling. You're strapped into a seat surrounded by 30,000 pounds of vibrating aluminum, high-octane fuel, and 5 tons of high explosives. Around you, the engines of 177 other bombers are coughing to life, a low-frequency growl that vibrates through the solace of your boots and settles deep in your chest. This is Operation Tidal Wave. As the wheels leave the sand, you aren't thinking about the arsenal of democracy or industrial quotas. You're thinking about the flying boxcar you're piloting. The B-24 is a beast, clumsy, heavy on the controls, and notoriously difficult to fly. To the men of the Luftwaffe, it's a massive, slow-moving target. To the men inside it, it's a coffin with wings. Fast forward 6 hours. The sky over Romania is no longer blue. It is a bruised purple, choked with the black smoke of burning oil and the gray puffs of 88mm flak. You're flying at corn cob level, barely 50 feet off the ground to evade radar. The heat from the burning refineries is so intense it blisters the paint on your fuselage. Suddenly, the tail gunner screams over the interphone. 190's at 6 o'clock. Hi. The German Focke-Wulfs dive, their 20mm cannon stitching lines of fire across the formation. You watch the B-24 to your left, the Eurocliper, take a direct hit to the wing root. In a split second, the massive Davis wing snaps. The bomber doesn't glide, it doesn't struggle. It simply cartwheels into the dirt and vanishes in a localized sun of orange flame. 10 men gone. By the time the sun sets over the Mediterranean, 54 bombers are missing. Over 500 airmen are dead or captured. In a single afternoon, the U.S. Army Air Forces have suffered a catastrophic loss that should, by all laws of traditional warfare, take months if not years to replace. But as the survivors limp back to the desert sands of Libya, something impossible is happening 6,000 miles away in a sleepy corner of Michigan called Willow Run. While the Luftwaffe pilots are celebrating their victory, a man named Charles Sorensen is walking a factory floor that stretches beyond the horizon. He isn't looking at the sky. He's looking at a stopwatch. He's not a general, and he's never dropped a bomb in his life. He is a foreman, a cast-iron man, and he is about to prove that the Third Reich isn't just fighting the U.S. military. They are fighting the moving assembly line. The impossible blueprint to understand the miracle of Willow Run, you have to understand just how much the experts hated the B-24. In 1940, the Consolidated Aircraft Corporation was building these bombers by hand. They were craft-built. A group of highly skilled mechanics would stand around a fixed jig, filing parts by hand, shimming wings, and custom-fitting bolts. It was slow. It was precise. It was artisan. They were producing on a good month 1 airplane per day. When the War Department asked Henry Ford to help build B-24s, the aviation establishment laughed. "You can't build a 4-engine bomber like you build a Model T," they said. An airplane is a delicate instrument. A car is a toy. In early 1941, Charles Sorensen, Ford's production genius, visited the Consolidated plant in San Diego. He watched the workers crawling over the planes like ants. He saw the chaos, the lack of standardization, and the agonizingly slow pace. That night, in his room at the Coronado Hotel, Sorensen couldn't sleep. He grabbed a pad of hotel stationery and a pencil. He didn't draw a plane. He drew a flowchart. He envisioned a building so large it would require its own weather system. He imagined raw sheets of aluminum entering one end and a fully fueled, combat-ready B-24 rolling out the other. Not once a day, not once a shift. He wanted a bomber every hour. The next morning, he showed the sketch to the Consolidated executives. They told him he was crazy. They told him the tolerances required for a 110-foot wingspan couldn't be achieved with mass production tooling. Sorensen didn't argue. He just went back to Detroit and told Henry Ford, "We can do it. But we're going to need a lot of concrete." Construction began at Willow Run in the spring of 1941. It was the largest factory under one roof in human history, over 3.5 million square feet. It was so big that the foreman had to ride bicycles to get from one station to another. But as the walls went up, the skepticism grew. The press began calling it, "Will it run?" instead of Willow Run. For the first year, the critics seemed right. The complexity of the B-24, with its 1.2 million parts and 313,000 rivets, was a nightmare. The first planes off the line were glitched and required hundreds of hours of rework. The aviation world waited for Ford to fail. They waited for the cast iron man to admit that you could unautomate the art of flight. What they didn't realize was that Sorensen wasn't just building a factory. He was building a machine that built machines. And once that machine started humming, no amount of German steel or Japanese Zeros would be able to stop the math of American production. The sheer scale was terrifying. But the real breakthrough didn't happen with a machine. It happened with a realization about the human hand. By the winter of 1942, the mud around the Willow Run site had frozen into jagged ruts, mirrored by the cold reality inside the plant's massive walls. The "Will it run?" jokes weren't just headlines anymore. They were a weight around the neck of every engineer on the floor. The problem wasn't the ambition, it was the Davis wing. The B-24's wing was a masterpiece of aerodynamic engineering designed by David Davis to be incredibly efficient at high altitudes. But it was a manufacturing nightmare. It was a 110-foot-long tapered blade of aluminum that had to be perfectly symmetrical. If it was off by even a fraction of an inch, the plane would pull to one side or worse, disintegrate under the stress of a 4-ton bomb load. Traditional aircraft builders said you had to build the wing in one piece, stationary, with a master mechanic overseeing every rivet. Sorensen looked at the wing and saw something else. He saw components. He ordered his engineers to do the unthinkable: break the B-24 down into 70 major subassemblies. The nose, the tail, the fuselage sections, and that impossible wing all were to be built separately on their own dedicated lines and then brought together at the final mating station. To do this, Sorensen introduced the fixture. Imagine a massive steel frame, 3 stories tall and weighing 30 tons, designed to hold the wing components in place with microscopic precision. These weren't the flimsy wooden jigs used in San Diego. These were massive, immovable anchors of industrial power. Once a part was locked into a Ford fixture, it couldn't move. Every hole drilled was exactly where the last one was. Every rivet was identical. But even with the fixtures, the human element was failing. The draft had sucked away the experienced male mechanics. To fill the void, Ford turned to a population the aviation industry had largely ignored: the unskilled. You're a 19-year-old girl from a farm in Kentucky. 2 weeks ago, you were milking cows. Today, you are standing in a roar of sound that exceeds 100 decibels. You're wearing heavy denim coveralls, your hair is tucked into a bandana, and you're holding a pneumatic rivet gun that kicks like a mule. This was the birth of Rose Will Monroe, the real-life Rosie the Riveter, who actually worked the line at Willow Run. The work was grueling. The factory floor was so vast that it had its own police force, its own hospital, and its own fire department. The fluorescent lights never turned off. The sun rose and set outside, but inside, time was measured only by the steady rhythmic thump-thump of the overhead conveyors. You didn't think about the war, one worker later recalled. You thought about the next rivet. You thought about the woman 10 feet down the line who was waiting for your piece. If you slowed down, the whole line groaned. This was the psychological shift Sorensen had engineered. By moving the planes on a continuous track, Literally pulling them through the factory at a speed of several feet per minute, he took the pace out of the hands of the workers and put it into the hands of the machine. If you weren't finished when the line moved, you had to move with it. The craftsmen in California hated it. They called it de-skilling the work. But Sorensen didn't want 1,000 master mechanics. He wanted 40,000 people who could do one specific task perfectly every 63 minutes. By mid-1943, the glitches were being ironed out. The flow of parts from the subassembly lines began to hit the main line with the precision of a heartbeat. The nose sections met the fuselages. The fuselages met the wings. The critics began to go silent. In Washington, General Hop Arnold looked at the production charts and blinked. In January, Willow Run produced 31 planes. In February, 75. In March, 107. The curve wasn't just going up. It was vertical. But as the bombers began to roll out the doors in record numbers, a new and terrifying problem emerged. The Luftwaffe wasn't just shooting down planes, they were evolving. New German tactics, heavier armor, and the introduction of the first jet fighters meant that a B-24 rolling off the line today might be obsolete by the time it reached the front lines in England. The military demanded changes. Thousands of them. They wanted more guns, better radar, and self-sealing fuel tanks. In a traditional factory, a mid-production change would grind everything to a halt for weeks. For a moving assembly line, it was a death sentence. How do you change the blueprint of a machine while the machine is already moving? Sorensen's answer would become the secret sauce of the American war effort, and it would involve a building that was never supposed to exist. The conflict was simple and devastating. Inertia versus innovation. An assembly line is a train that cannot stop. Once Sorensen's 3.5 million square foot machine was in motion, changing a single bolt meant recalibrating hundreds of fixtures. But over the skies of Germany, the war was changing every week. The Luftwaffe had discovered a lethal flaw in the early B-24s. They lacked a nose turret. German pilots were flying head-on into the formations, shredded the glass greenhouse noses where the bombardiers sat, and veering away before the waist gunners could even blink. The Army Air Forces demanded a nose turret, immediately. For any other factory, this would have been a catastrophe. To add a turret, you had to redesign the entire nose section, redistribute the weight, and change the wiring harnesses for 1,000 feet of cable. If Ford stopped the line to retool, the flow of bombers to Europe would dry up for months. Sorensen's solution was a stroke of organizational genius that became known as the Modification Center. He realized the factory shouldn't be a closed loop. He kept the main line running, producing the standard B-24s at a blistering pace. Then, he built a series of massive hangars at the end of the runway. As the bombers rolled off the assembly line, they didn't go to the front. They went to the Mod Center. There, specialized teams would perform the surgical upgrades, installing the latest radar, the nose turrets, or the new oxygen systems before the planes were flown to the theater of war. It was a hybrid system. Mass production for the skeleton, custom craftsmanship for the brains. The 63-minute miracle by 1944, the Willow Run? Skeptics weren't just silenced. They were terrified by the answer. Willow Run had reached a state of industrial flow that defied the laws of physics. To see it was to witness a symphony of steel. Imagine you are standing at the mating station. This is the heart of the factory. Above you, overhead cranes carry 55-foot wing sections as if they were feathers. Below, the fuselage section's gigantic aluminum cylinders are moved into place on tracks. The air is thick with the scent of alkylate aluminum and cutting oil. There is no shouting. The workers move with a choreographed grace. A team of women, nicknamed the California Girls because they worked on the wing-to-body joints, would dive into the tight spaces of the wing root. They had 60 minutes to connect hundreds of wires, fuel lines, and control cables before the line moved again. 63 minutes. That was the benchmark. Every hour and 3 minutes, a bell would ring. The line would lurch forward exactly 1 station length, and at the far end of the plant, a door the size of a city block would slide open. A brand new B-24, its silver skin gleaming under the Michigan sun, would be towed out onto the airfield. A test pilot would jump in, fire up the 4 Pratt and Whitney engines, and within 2 hours, that plane would be heading for the staging grounds in Kansas or New Hampshire. At its peak, Willow Run was producing 432 bombers a month. To put that in perspective, the entire nation of Japan, with all its industrial might and forced labor, was struggling to produce a few dozen heavy bombers a month. Ford was producing a 4-engine long-range heavy bomber faster than the Luftwaffe could shoot them down. But this speed came at a staggering human cost. The factory was a pressure cooker. The Ford way was relentless. The company's service department, a polite name for Henry Ford's private security force, roamed the floors, ensuring there was no idling. There were no chairs. No breaks except for a 15-minute lunch eaten standing up next to a vibrating machine. The workers were living in Bomber City, a makeshift town of trailers and tents surrounding the plant. The mud was knee-deep. The schools were overcrowded. The tension between the local farmers and the 40,000 outsiders who had descended on the valley was reaching a breaking point. And then, just as the machine reached its absolute zenith, the war threw one final, unexpected curveball. The military didn't just want more planes anymore. They wanted a different kind of war. Rumors began to filter down from the high command about a new project, something called the B-29 Superfortress. It was bigger, faster, and carried a weapon that would render the B-24 obsolete. The cast iron man, Charles Sorensen, looked at his 63-minute miracle and realized that the very system he had built, the rigid, unstoppable line, was now his greatest enemy. If the government canceled the B-24 contract, the largest factory in the world would become a 3.5 million square foot tomb overnight. But as the sun set over the Michigan forest in late 1944, a telegram arrived that changed everything. It wasn't from the War Department. It was from the front lines in the Pacific. The B-24s weren't just being used for bombing anymore. They were being used for something impossible, something that would require the workers at Willow Run to break their own records one last time. June 5, 10th, 1944, 1,500 miles west of Hawaii, over the Central Pacific. The cockpit of the B-24, the Dragon and his tail, is an oven. Outside, the sun reflects off the endless blue of the Philippine Sea with a glare so intense it bypasses your flight goggles. You are thousands of miles from the nearest paved runway. In the European theater, a B-24 might fly for 6 hours. Here, in the Pacific, your missions are 14, 16, sometimes 18 hours long. This is the war of distance, and the B-24, thanks to that high aspect ratio Davis wing, is the only heavy bomber that can bridge the gap. While the B-17 Flying Fortress gets the headlines over Berlin, the B-24 is doing the dirty, lonely work of the Pacific. It is the tanker, the transport, the reconnaissance eye, and the snooper, a specialized night bomber painted pitch black, flying at mast height to skip bombs into Japanese destroyers. But back at Willow Run, the cast iron man Charles Sorensen isn't thinking about the Pacific. He's looking at a terrifying new set of numbers. The Army Air Forces had realized that the B-24 wasn't just a bomber, it was an industrial consumable. They were losing them faster than they could be repaired, but slower than Sorensen could build them. The logic of total war had shifted. It was no longer about preserving the aircraft. It was about overwhelming the enemy's ability to count them. The human cost of 63 minutes inside the plant, the 63-minute bell has become a heartbeat. But the people under the lights are fraying. You're a mating station lead. You haven't seen your kids in daylight for 6 months. You live in a hoverette, a tiny prefabricated plywood house with no insulation. When it rains, the Michigan clay turns into a soup that swallows tires. When it freezes, the wind off the lake cuts through the factory walls like a scalpel. The pressure to maintain the 63-minute pace has created a unique kind of combat fatigue on the home front. The Ford Service Department men the enforcers patrol the aisles with stopwatches. If a worker faints from the fumes of the zinc chromate primer, they are dragged off the line and replaced within minutes. The line never stops. It cannot stop. By early 1945, Willow Run had become a city of 42,000 workers. They were producing more than just planes. They were producing a new American middle class. High school dropouts from Appalachia were making more money in a month than their fathers had made in a year. Sharecroppers from the South were becoming master electricians. But the machine was outrunning the war. In April 1945, the inevitable happened. The War Department looked at the stockpiles. They had enough B-24s. In fact, they had too many. The flying boxcar that had been so desperately needed in 1942 was now crowding every airfield from England to Okinawa. The order came down: cease production. The transition was as violent as the startup. On June 28, 1945, the final B-24 number 8685 to be built at Willow Run rolled off the line. The workers gathered around it, many of them in tears. They had signed their names inside the fuselage, tucked notes into the wing spars for pilots they would never meet, and poured 3 years of their lives into this silver beast. As the engines of the last Liberator roared to life and it climbed into the Michigan sky, a strange silence fell over the 3.5 million square feet of the factory. The overhead conveyors groaned to a halt. The rhythmic thump of the rivet guns died away. In just over 3 years, one single building had produced nearly half of all the B-24s ever made. It had transformed the way humans build things, proving that even the most complex machine on Earth could be broken down, automated, and conquered by the moving assembly line. The legacy of the cast iron miracle. Today, the B-24 is a rarity, a museum piece that looks small and fragile compared to modern jets. But the legacy of Willow Run isn't found in the planes that survived. It's found in the world they left behind. Charles Sorensen's impossible blueprint didn't just win the war. It defined the 20th century. The techniques perfected at Willow Run, the massive steel fixtures, the sub-assembly mating, the just-in-time logistics became the DNA of the modern world. Every Boeing 787, every Ford F-150, and every smartphone you hold is a direct descendant of that 63-minute miracle in the Michigan mud. The cast iron man had shown that in the age of industrial giants, the greatest weapon isn't a bomb or a bullet. It's the ability to organize tens of thousands of hands into a single, unstoppable machine. The Luftwaffe had more experienced pilots. The Japanese had faster fighters, but they never had a chance. Because they weren't just fighting an army. They were fighting a factory that didn't know how to say no.